Through this door lies another dimension. A dimension not only of sight and sound, but of a rational mind. Between science and superstition. A dimension that begins in the pit of man's fears and plumbs the depths of his ignorance. You are about to enter the Flerf zone. Einstein once told us that if you can't explain something simply, you don't understand it well enough. But what happens when an idea is oversimplified? Enter Eric Dubay, a man as devoid of intelligence and understanding as this barren landscape. A study in oversimplification, logical fallacies, and a pathetic attempt at cult building. Submitted for your approval tonight on the Flerf Zone.
Long before the theory of gravity was a glimmer in Newton's imagination, the natural physics of density and buoyancy already perfectly explained why apples fall down.
No, they did not. They explained why things float in water or in air. And there's no such thing as a perfect explanation. At least not yet. But notice Eric Dubay's use of language. He says Newton's imagination, as if he's trying to equate imagination with imaginary. All scientific inquiry starts in the imagination by asking the questions, what if, how does, how come? It's almost as if Eric Dubay is trying to convince us how to think.
Quite simply, objects fall or rise based on their relative density to the medium surrounding them.
An imperfect explanation. We must also take into account the temperature and viscosity of the fluid or the gas. We must also take into account the relative mass and displacement of the objects in question. Take the cherry tomato in the soap, for instance, in this example. It stopped at that level because their density and mass has equalized, and it was gravity that allowed the soap molecules to come together as a liquid in the first place, and the cherry tomato to sink to that level.
Apples fall because they are denser than the air, while helium balloons rise because they are lighter.
Apples fall because gravity accelerates it towards the center of the earth, and the crust of the earth, or the grass, gets in the way and stops it. If density were the only thing in play, apples wouldn't fall down, they would fall up, because the air is less dense above than below. Therefore, another force must be acting upon the apple. We choose to call this force gravity. Newton could have used the word charisma and been just as accurate. Yes, helium balloons will rise, because the helium is lighter than the air around it, but only so long as the balloon continues to displace the air.
No gravity necessary. This is why raindrops fall down through the air, and air bubbles rise up through water. Everything seeks its relative density and rises or falls until settling accordingly.
But gravity is necessary, otherwise raindrops could not even form. And again, if it was all density, then the raindrops would fall up, since the air is less dense above than below.
This is why a tiny pebble sinks to the bottom of the ocean, but gigantic cruise ships and aircraft carriers stay afloat on the surface, because even though a pebble is so small, its mass relative to its volume, its density, is more than water, so it sinks. And even though a cruise ship is so large, its mass relative to its volume is less than water, so it floats.
But steel is more dense than a stone. So why does the stone sink and the ship float? There are multiple things at play here. One is the shape of the stone versus the shape of the ship, which has to do with displacement of the fluid around it. Another has to do with the void spaces of the ship, which changes its buoyancy, yes, but does nothing to change its mass or density. And the gravity acting upon the ship is spread out over a larger area, than if the same mass of steel were molded into a lump.
If Newton's apple had landed in a puddle instead of on his head, he would have seen the apple only fell through the air because it was denser than the air, but then floated on top of the water because it was less dense than water.
I find it incredulous that you think you know what was in the mind of Newton. And no, the apple didn't really fall on his head. That is just a story.
Have you ever noticed how it's easier to stay afloat with your lungs full of air than it is when they're empty?
Yes, because the air in my lungs is changing my center of buoyancy. What's your point?
Submarines float on the surface when their ballast tanks are filled with air, but when the vents are opened and seawater floods in, they begin to sink as the submarine's density becomes greater than water. Depending what depth they wish to dive, sailors simply adjust the ratio of air and water in their tanks, and when ready to resurface, they blow compressed air into the tanks, forcing the seawater out, lowering the density, and thus causing them to rise back to the surface.
Not only is it changing the density, but it's also changing the buoyancy. This is called negative buoyancy to make it sink, and positive buoyancy to make it float. But yet again, air is less dense than water. Why doesn't the submarine float in the air instead of in the water? The answer is another force is acting upon the submarine, known as gravity.
We can also prove this fact of relative density by filling a balloon with approximately half helium and half air. Since helium is lighter than the oxygen, nitrogen, and other gases that compose the air around us, filling a balloon with just the right amount of helium to compensate for and balance out the density of the plastic results in a gravity-defying, levitating balloon at equilibrium that neither rises nor falls.
This balloon is not defying gravity. Gravity is still keeping it from floating off into space. What is happening is that the balloon has ceased to displace the air around it, which was causing it to rise.
How is it that gravity is so strong that it can hold all the oceans, buildings, and people stuck to the underside of the ball Earth, but so weak that it allows birds, bugs, smoke, and balloons to casually evade its grips completely? How is it that gravity holds our bodies clung to the underside of a ball Earth, but yet we can easily raise our legs and arms, walk or jump, and feel no such constant downward pulling force?
Because gravity is a weak force, not a strong force. It is not magnetism, and we can temporarily overcome the effects of gravity. And you do feel the effects of gravity when you raise your arms, or your legs, or anything else. Because when you relax, you have to fall back to where you began. Once again, if it were all density and buoyancy, you are more dense than the air around you. The air above you is less dense than the air below you. You would float without gravity.
How is it that gravity can cause planets to revolve elliptical orbits around a single center of attraction? Ellipses by nature require two foci, and the force of gravitation would have to regularly increase and decrease to keep planets in constant orbit and prevent pulling them into direct collision courses. Einstein's theory of relativity and the entire heliocentric model of the universe hinge upon Newton's law of gravitation. Heliocentrists claim that the Sun is the most massive object in the heavens, more massive even than the Earth, and therefore the Earth and other planets, by law, are caught up in the Sun's gravity and forced to orbit perpetual circles and ellipses around it. They claim that gravity also somehow allows people, buildings, the oceans, and all of nature to exist on the underside of their ball Earth without falling off.
Your pseudo-zetetic philosophy, in which you offer no explanation of your own and only offer more question, yet again, is becoming quite tedious.
Now, even if gravity did exist, why would it cause both planets to orbit the Sun and people to stick to the Earth? Gravity should either cause people to float in suspended circular orbits around the Earth, or it should cause the Earth to be pulled and crashed into the Sun. What sort of magic is gravity that it can glue people's feet to the ball Earth while causing Earth itself to revolve ellipses around the Sun?
A false dichotomy at its worst. This is not magic. It's physics. You are conveniently forgetting orbital velocities. Now, if we launched you out into a space with enough velocity, you would orbit the Earth, and if we gave you even more velocity, you would orbit the Sun. Now there's an idea.
The two effects are very different, yet the same cause is attributed to both. Furthermore, this magnetic-like attraction of massive objects gravity is purported to have can be found nowhere in the natural world. There is no example in nature of a massive sphere or any other shaped object which, by virtue of its mass alone, causes smaller objects to stick to or orbit around it.
Yes, there is. It's called the Earth. Your argument of incongruity is also wearing thin. So is your appeal to ignorance, in which you're hoping your audience is too uneducated or ignorant to find out for themselves what kind of fool you are.
There is nothing on Earth massive enough that it can be shown to cause even a dust bunny to stick to or orbit around it.
Except for maybe, I don't know, the Earth?
Try spinning a wet tennis ball or any other spherical object with smaller things placed on its surface, and you will find that everything falls or flies off and nothing sticks to or orbits around it.
Probably because the mass of a tennis ball does not match the mass of the Earth. But even then, the centripetal force will not get rid of all the water off the tennis ball.
To claim the existence of a physical law without a single practical evidential example is hearsay, not science.
Except for all the evidence that does exist, and all the examples that do exist, of which I've only given you a few here in this video. But before you really hurt yourself severely with your attempts at thinking, I will offer yet another piece of evidence. And rather than recreate his work, which would be pointless, I have asked BM FurBall Pancake Hero to join in this little party of ours. You can find his link to his channel and his video in my description box.
Today we're going to look at a historical event that I feel confirms gravity as a force in the cosmos. For much of the past 2,000 years, astronomers have believed that the Earth was the center of the universe, and that all other objects orbited around it. But in the early 1500s, Nicholas Copernicus developed his idea of heliocentrism, placing the sun at the center, not man. With this belief, Copernicus created his 7 assumptions that heliocentrism is based. There is no center of all celestial spheres. The center of the Earth is not the center of the universe. All observable celestial spheres surround the sun as if it were the middle of them all. The distance from the Earth to the sun is greatly smaller than the distance from the Earth to the celestial sphere. Whatever motion appears in the celestial spheres is not from their motion, but rather from the Earth's motion, while the heavens remain unchanged. The rise of the sun is not from its motion, but rather the Earth's revolution. Retrograde motion of the planets is not from their motion, but both bodies' orbit of the sun. These beliefs shook many astronomers to their core, because it called into question the ancient supposition that the Earth and man were the center of everything. Following on Copernicus's work, Danish astronomer Tycho Brahe continued the work of conducting sky surveys. Brahe meticulously cataloged the movements of the planets, creating exact historical records of the precise location of Mars in the sky as it went back and forth season to season. He saw the benefits of Copernicus's use of geometry to predict the motions of the planet, but he still espoused mostly geocentrism ideas. In 1609, Building on the giants that came before him, Johannes Kepler published his first works on the laws of planetary motion. Kepler used the precise observations of Mars, provided by Brahe, to determine that planets didn't actually orbit in perfect spheres, but rather ellipses, and that based on their distance from the Sun during these elliptical orbits, their speed would vary. When closer to the Sun, the speed increased. When farther away, it slowed down. While Kepler didn't necessarily understand why the orbital mechanics worked this way, he was able to precisely predict their location in the sky year after year. The why of orbital dynamics wasn't answered until 1687 by Sir Isaac Newton and his laws of universal gravitation. Newton theorized that objects attracted each other based on their distance and mass. This series of advances and discoveries is the basis of much of today's physics and astronomy, and it brings us to the purpose of today's video: the odd orbit of the planet Uranus. In the late 1800s, William Herschel was conducting further detailed surveys of the sky, looking for comets. Most comets, similar to all planets, orbit the Sun in a flat disk around the solar system, called the ecliptic. On the Earth, this is seen as a straight line across the sky where all wandering bodies can be found. Knowing this, Herschel focused his survey on this narrow swath of the sky. On the 13th of March, 1781, Herschel found what he believed to be a new comet, stating, "I don't know what to call it. It is as likely to be a regular planet moving in an orbit nearly circular to the Sun as a comet moving in a very eccentric ellipsis. I have not yet seen a coma or tail to it." Follow-on observations by other astronomers determined this was not a comet, but rather a newly discovered planet, Uranus. Over the following 40 years, astronomers across the world observed this new object again and again, and like all other planets before it, precisely plotted its orbit around the Sun. And using the laws established by Kepler, they were able to predict its future progress across the sky, until the 1830s and 40s, when irregularities were found, not only in the ecliptic location above or below the line, but also in its distance from the Sun. Some astronomers theorized that maybe Newton's laws of gravitation didn't remain the same at great distances, while others began to believe that maybe a massive object was located outside the orbit of Uranus. Unknown to each other, British astronomers John Adams and French native Urbain Le Verrier began to use Kepler's laws to see if there was in fact another body deep in the solar system. Le Verrier made multiple publications on his estimates of the planet's location, but not its orbit or its mass. He did this by placing a notional body at certain locations around the Sun and extrapolating what that body's effects would be on Uranus. In theory, as Uranus swept past this object, its gravitational pull would cause a change in the natural orbit of Uranus. Finally, after proposing the position, orbit, and mass of this body, Le Verrier made a bold prediction of its exact location in the sky and sent it to his friend, Johann Gottfried Galle, at the Berlin Observatory. And on the evening of the 23rd of September, 1846, just after midnight, Galle turned the observatory's telescope to the precise location predicted by Le Verrier and found Neptune less than 1 degree from its predicted location. After 2 further nights of observations, it was confirmed this new body did move behind the background of stars. Galle anxiously replied to Le Verrier, "The planet whose place you have computed really exists." Using nothing more than sheer mind power and math from information gathered over the last 2,000 years and the great minds of Copernicus, Brahe, Kepler, Newton, and Herschel, Le Verrier was able to predict the exact location of something that was unseen.
Thank you, BM FurBall, Pancake Hero. I encourage everyone to check out the rest of his video and the rest of his content. He's got some really good stuff. And I know this was a long video compared to what I usually do, but it was in response to a troll challenge who didn't think I could debunk his hero, Eric Dubay. I know better than to expect Mr. Troll to admit that I'm right on anything, which is okay. If he's brave enough to show up here and leave troll comments on this video, I call open season on trolls. Thank you for watching. I know how precious your time is.